All right, so now that you all have had a chance to just want to warm up, what's your experience with computer programming? You're about to answer. What's your nothing? Does anyone have any experience with computer programming, computers? Oh, okay.
Last year we used a lot of these type of computers and we did like recording and stuff. I don't know what computer science is, but I know how to use a lot of computer programming.
So just like video editing, stuff like that? Okay.
In 10th grade, I was in a robotics club, and we had to use C++ to program robots. And this year, I'm in Technovation, and we use MIT App Inventor, which uses block editing, so it's really simple, to program Android applications.
Yeah, that's tight. Okay, so you said like some really like important keywords. What's C++?
It's a type of program used to, well, program things. Yeah, it's a certain type of application.
Okay, so like C++, like, yeah, that's a lot of like, Lillian has intense experience with this obviously, but C++, computer science deals with programming. So you use different programming languages, which involves code. So it's really complicated, well not too complicated, but it deals like a lot of logic and math, and it basically runs technology. So that computer works off a set of programming, set of rules, and you'll see as you get adjusted to the net logo. So let's get started. So did everyone open net logo?
Yeah.
Okay. So right now I'm going to give you like each about 5-10 minutes to explore. So on that logo you have a screen like this, right? Everyone? Yeah? So go into File on that logo and then open the Models library. And so when you do that you get a bunch of different options, like all these different subjects. So choose a subject that interests you. Let's say chemistry, because I'm chemist. And then choose one of the models, like let's say, what is this gas chromatography about? Right? So it doesn't, you don't have to choose a specific one, but it'll open up another model window. And on this window, open the info tab, read a little about what the model does. You don't have to read everything, read like how it works, what it's about, and then just explore, mess around with it for about a little bit, and then we're gonna reconvene and discuss.
Oh, no.
So if you have problems too, raise your hand if you don't understand what's going on. I'll be walking around. Try clicking on like the player thing. And like they even have games on it, like Pac-Man or something. It's not too scientific though. Okay, so random balls. This is one I'll chose. So let's go to the info tab up top. And then so it's, what is this? It simulates frictionless billiard table window. So how it works, balls are drawn in green, they move in straight lines, bounce off balls. So basically just like skim this, kind of mess with it, press setup, and like you can change the number, right? So let's say there's 272 balls, and you press go. It just does that. So like this is some crazy, what is this doing right now, right? So just explore info and like understand what it's doing, like, you know what I'm saying? Do y'all know what that is, or? What model is it?
It's like the sheep and the wolves.
Okay, so have you read the info tab on it, or like skimmed it? So like the way you start the model, press setup on every model, and that's how it sets up the certain statistics you use. So like for example, if you want to go back to the interface, you don't even really need to know what every detail is, just press setup. And then press C, like it all pops up, press go, and you can see like what happens, it's moving, it's graphing, right? So like all these statistics right here, you can change them, like the initial number of sheep. This all follows the formula right now. Do you understand what I'm saying? It's like there obviously isn't a lot of wolves here because the sheep are just reproducing like crazy, right? So like how would you change the number of like sheep at the end? Like decrease the amount of sheep.
You would either increase the number of wolves or decrease their reproduction rate.
Yeah. So like try that right now. Or like press setup again to stop it. Or actually change the statistics and then press setup. So like you increase wolves to that. See, there's more wolves, there's more interaction going on. Alright, so we're going to have to move kind of fast. Not kind of fast, but because we have a lot to cover. But is everyone on a model? Anyone want to share their model?
Just black screen.
What?
Just a black screen.
Okay, well, which model did you choose? Okay, so like on this black screen. Yeah, so that, what is this? What model is this? Pictures? Press, we have to press one of those buttons, right? Like new.
Oh.
And then play. See, you just have to like make sure you start the model first with conditions. All right, anyways, so what models did everyone mess with? The Pac-Man one? Okay, like, I recommend not using the games because they're not as interesting because, like, you know those games, right? Like Pac-Man and everything. So try to use a different model. They don't really simulate that good of an environment that well. But how about other groups? Any other groups find any interesting models?
We chose the fire model from Earth Science.
Okay, what's that do?
It simulates a forest being set on fire.
Okay, so let me find this fire model. What subject was it in?
Earth Science.
Earth science. So this is the model they chose. So you can like look in the info tab, gives you a little synopsis if you're more interested on this later. But basically, you have to set up the model first with whatever conditions you chose. So there's a density factor of like say 63%, set that up, and then you press go. And it's modeling the spread of a fire through a forest, it looks like, and it counts like how much is burned over time. So like it looks really cool, there's all these colors going on, right? And then how much of the forest is left. That's my initial guess, and you can check it. So anyone else have any other interesting models or explorations they went through? Pac-Man. Yeah, what about Pac-Man? I don't know. Yeah, it's just Pac-Man, you know, like, ain't that cool. But anyways, so basically what is NetLogo? Does anyone have an idea of like what the purpose of this is? Like why someone would want to make a computer program like this?
Because they're bored.
Because they're bored.
Doesn't have nothing to do with it.
Well, I mean, like, there's always a reason beyond like being bored. Like, maybe that is a reason, but like, I doubt someone would invest this much time and money. Like, a lot of like companies are really like endorsing this just because they're bored. Like rack your brains. Like, I'm pretty sure someone has an idea of like why someone would want this. Like, why would you want it?
They model real life systems.
Yo, that's perfect. That's exactly why. So that actually like hit the nail on the head. This models real life systems. So basically, it models real life systems. So they choose like any system, any subject, anywhere. It could be a society. It could be like a particular pattern in biology, and like you can set it up with all these different factors, and you can tweak these factors in a way that you can analyze and manipulate and like study the system better. So like say you're a scientist, a social scientist, you can get like a better understanding of what this does, right? So basically like NetLogo works off the basis of turtle geometry. Does anyone know? I doubt that anyone knows, but Lillian has some experience. Does anyone like over there with experience know what turtle geometry is, what that could possibly mean? No? Okay, so like each object in NetLogo is called a turtle. So like each little individual object, like I know y'all were working with like a sheep and wolf program over there. It's like each one of those sheep, each one of those wolves is called a turtle in NetLogo programming language, right? So a turtle is just like an individual object, And the coder, the programmer, programs and writes the rules that define the movement of that turtle. So basically, as the programmer, you're defining the rules that that turtle has to move by. Okay, so for instance, let's say I'm the turtle, right? So, and y'all are the programmer. So try to like program my movement right now by telling me what to do. So let's say I want to move from here to that end of the room. What would you tell me to do?
Walk straight.
So I'm walking straight.
Start
Turn
working.
Stop what?
Start working.
Start working. I mean, you can make the turtles work if you want. That's not going to get you to the wall. But like, how would you get me to the wall? I'm walking straight, I'm hitting this, I can't move. Like, someone put a desk here in this matrix. Like, how would you make me as the turtle move?
Hop over the table.
I'm trying to get to that wall though. So like, someone else in the class do something input. How about y'all? Like, how do you think I could get from here to there as a turtle?
Walk around the desk.
Okay, so I'm walking around the desk. Yeah. I mean, like, I'm going to walk around this desk continuously because I'm a turtle. Because I have no brain right now. These turtles don't know, they can't
Turtles
move
can be
themselves.
stupid.
So how would you get me from this to that wall? I mean, it's not that hard. Like,
Walk to the door.
We just tell you to go.
yeah, just tell me what to do.
Go left.
Go left, so I'm going left.
Oh, wait.
So if he's telling to go left, I'm continuously turning left, right? So if you're continuously turning left, you're turning in a circle. So like, someone give me more specific instructions.
Stop. Turn right until you see a cabinet. When you see a cabinet, stop. Go forward 5 steps. 1, 2, 3, 4, 5. Stop. When you go left at a 90-degree angle. Oh crap! There's a desk.
Hop over them. Do the matrix.
Well, walk forward until you hit a chair, then stop. Oh, well, I was going to assume you hit that
I mean,
chair.
you can use
And then I
chairs and
can't
markers.
see. Okay, T, your turn. I can't see over there because people are in the
Alright,
way.
so you tell me how to get from here. Well, you're almost there, right? Like the goal's almost accomplished. Okay, so I'm walking out this table. There's a wire right here. This turtle's about to die. Go over the wire. So I'm walking out this table. Stop. Turn right. 90 degrees.
Face
Forward.
palm.
I'm at the wall. So good job, class. Like, you programmed me as the turtle to get from there to the wall, right? So obviously that code wasn't the most efficient code, right? I was like hitting that desk there for a little while. I was like bumping the chairs. So that's what a programmer has to do, right? They're trying to write a code to make a turtle do something, to make a turtle model something. And because like this turtle can't think for itself, you can't just tell the computer like turn right. Because then something's going to happen, something's wrong going to happen, and the bug's going to come up. So as a programmer, you need to be efficient. You need to be, how can I get this turtle to do this in the least number of steps for it to accomplish this goal? So that's what NetLogo programmers are doing. They're coding, and they're trying to make this system, they're trying to work these turtles to move a certain way. Like, this might look simple, like you just clicked a few buttons, but if you all just like switch to the code tab a little bit, that's a NetLogo programming language. This is an entire language like Spanish or Japanese, something you learn in a class. Except it's like, it's all in English, whatever your chosen language is, but it still like works according to a certain set of rules. Like if you look at this, you can like make out words, but what does this mean? It's a specific format that dictates what you're doing. So now we're going to move on to the actual lesson. So open the models library again, and then the model we're working with today is in the mathematics section. So everyone click on mathematics. And we're going to open the turtles lesson, turtle circling. So is everyone at turtle circling? Yeah? All right. So I'm going to give you each like another 5 or so minutes to go into the info tab, try to figure out what the model is trying to model, mess around with it a bit, and then we're going to remarshal and start tackling the task. So everyone read a little bit about turtle circling, and then I'll be walking around. don't read everything word for word. Try to skim it since we don't have too much time. Try to like get the main facts out so we can move on to the task. So things to try. Like this one. So have you all read the first part? Alright, so we did the interface. Do you understand what I was trying to model? I'll let you some time to listen. How about you? Have you started like modeling anything, right? So like, remember press setup before to institute the number, like the factors you choose. And then once you choose those factors, press go as well. Or I mean, all circle. Oh, there's a set of instructions on the handouts we gave out. If you have any questions on them, if they're not clear, like I'm always here as a resource. But it's like a general guideline to operating turtle circling.
Let's go back there. Explain draw a circle. Draw a circle.
Alright, so has everyone had like a chance to explore? Messing around with, there's a lot of like cool colors, cool patterns and stuff, right? So did anyone find anything interesting? You all like really absorbed right now. That's a good thing. Man. Okay, so like, can I get your attention real quick up here? Alright, so you set up, okay, let me move this down a little. You set up a number of turtles, right? Like let's say we have 78 turtles. And you can choose the speed they turn, the radius they turn at. So they're all circling, right? And has anyone used the pen down function? I saw a few people using it. It basically traces the path of your turtle.
Oh, is that what that is?
Yeah. And you can actually set the shape of your circle to a turtle. So you're literally dealing with turtles. That's kind of cool, right? And then, so in this, you can change the radius at which they turn at, make all these crazy colors. And because we have the pen down function active, it's tracing each turtle's individual path according to the color. So while they're turning, you can just keep changing the radius, make all these crazy patterns and whatnot, increase the speed. It's really like trippy and kaleidoscope-like. But yeah, like if you think about it, life is all about programming in effect. Like life is about patterns, and programmers recreate those patterns in a computer and in a technological environment. That's why computer science is so cool, because it's basically you're coding the rules for your own little reality. You put it in that way. So did anyone find anything interesting? Like any cool patterns anyone made, or what is that? Are those the turtles? Okay, that's tight.
What do we do?
So like, what did you do like to get those patterns, right? Like, there's math to this. There's code to this. It isn't. It looks random, or it might look random. All the different factors you're messing with, but it's all part of a pattern. Like, there's a reason. There's a certain radius change you went through, a certain speed you went through to create that pattern. It's all explainable. So basically, we're going to move on to our task to help dissect each one of these patterns one by one. So on the handouts, we have our first task, right? So I want each group to try to move through these tasks as fast as possible. If you finish them, I have an extension problem. If you have any questions about the task, about predictions of patterns, I'm here. So just explore it and try to get a grasp on this program right now. And I'll be moving around. They don't have like a task hangout. Other. So if you want to start over the patterns again to the original setup, just press setup and then it'll restart it and so you can like, go on the task or do what you need to do.
I mean something I think.
Freaking steroids.
What outcast? Is it outcast?
Yeah. I mean, don't worry too much about the tasks even, because like looks like most of y'all are making cool patterns and stuff. So that's important too. Like, but try to get a grasp on like the patterns you're making, what's happening, like what you did to make that pattern, like how you changed the radius, what the turtles are doing mathematically.
So, all the 0 turtles complete 1 full circle. So that means the 0 circle?
Okay, so see y'all working on the task. Which one is this? Number 1? Okay, so did you predict that pattern?
No.
No? So what did you predict to happen? Do you understand what's happening though? So like you started off with you decreased the radius, right? So like what is the radius? It's half of the diameter of the circle, right? So when you decrease the radius, so you decreased it at this point, right? So the turtle is moving right here, and right at this point you chose to decrease the radius, right? So the turtle just received instructions from the code, okay, so the radius is smaller, right? So just like I did, it had to switch up its movement real quick. So it decreased, like, okay, I need to start moving in a smaller radius. So it swerved off the path and started moving in a smaller radius. So if you increase the radius right now, at that point, the turtle would receive new instructions, start moving at a larger radius at the point where you told it, and it would intersect right there with that circle. Do you understand that? Sure, good job, bro. Yeah, like this isn't as like flashy as the patterns one though, but like it's a good way to like understand it like simplistically.
What's the spiral
How did y'all like what is happening?
But this time, using
Like how is it changing so much? Like how did it make all these different patterns, right?
What's up, bro?
Why is it like when it gets bigger, like it goes out of the screen, like there's multiple circles? So like do y'all have any theories on why it is like moving the way it's moving, showing the patterns it's making?
It interacts with the size of the window.
Yeah. So like when it moves out, there's certain limits to which you can view it in, right? So that's why you see like the circle like has like only partial parts shown right here.
What is that turtle always?
The radius gets so large.
That's great, right?
Yeah.
Alright, that's good too.
Turtle.
I don't know what we're supposed to do right now. Oh,
Stare at the one round turtle.
So also, like, even if you're not following the task, I want y'all to check out the graph at the bottom. So, in addition to making these intense visual displays, at the bottom, each time you set up, the graph should be graphing the turtle's distance from the origin over time. So there is a purpose to pretty displays like this. Like it gives you quantitative data. It shows you, in this example at least, a graph of distance over time. So just check out like how the graph changes as you move your turtles. So after a certain point, the graph starts graphing because it goes off the graph over time. So to change that and have it continue to graph, just press setup again and start moving again. You should see the graph changing. So like, if I did that, it starts graphing because it's not out the window yet. So as you can see, it has these different spikes. So try to interpret the graph as you move your turtles. I feel like that's an important point to dissect.
Huh? Okay, I'm gonna do all the turtles. Okay. You're gonna
Okay, so like the draw circle, like that, it creates like a base circle, so like you can like measure it relative to that circle. So like change the draw radius of the base circle, and then press draw circle or whatever again. It makes it smaller. So like as these are moving, the circle will stay constant. So you can have like a centerpiece to compare it to.
Predict the graph. Okay, no, wait, we just use this one.
That's crazy. It looks like spiders. Like a spider web.
Are we doing this?
Predictive graph.
Do you understand what that means? It's like, what is that graph? You don't have to tell me exactly, but what is the general like shape of that graph mean? Like, there's a lot of sinusoidal spikes, right? So it's going up and down, like a bunch of times. What does that correspond to? As a turtle moving as you're directing it.
It's distance from the origin.
Yeah, right. So why is it going up and down though?
Because as it goes farther away,
Yeah.
then it's farther. But then once it hits the farthest point away, it'll start coming back.
Yeah, so it's circulating, right? So you know what the shape of a circle looks like? It's like a trig graph basically, like a sine graph, sine of x, cosine of x. So that's basically what it's graphing right now. Does anyone have questions on the graph, on the function, anything like that? Any cool patterns, explanations for cool patterns? I know some of y'all had some cool patterns. Someone like volunteered some information. Like, what did you discover through this?
use them normal.
We use normal terms. Okay.
They're not normal.
Well, I mean, like this isn't a normal program.
Huh? Oh.
Okay. What did you find? Like, and how did you find it?
I was messing around.
Okay. But what did you get from messing around?
There's always one random turtle.
I don't know. You can change the pattern. Then you change the radius.
So like you have a pattern right there, and like, what happens when you're making it smaller, right? What are you changing?
The radius.
Yeah.
And then you make a different pattern.
So just like simple explanations like that. All right. So real quick. All right, can I have everyone's attention back on the board again? Pause the model real quick. All right, so as you can see right now, I'm on the code tab. So everyone go to the code tab on Turtle Strickland. So basically, these are the rules. This is the programmer telling the turtle what to do. It looks pretty crazy, but this is what you deal with in computer science. So for example, right here, to move a long circle of radius, you're having the turtle move forward. FD means move forward by this certain formula, and then it moves right at the speed divided by 50. So these are all abbreviations for certain instructions given to the turtle. So I'm not too familiar with NetLogo programming language, but if you try to dissect through this code, you can kind of make out what it's trying to tell. So it's setting up the circle right here. Each one of these is a function. So a function is a general formula for the turtle wherein you input information and then it makes the turtle move. So you all have dealt with functions in pre-calculus, right? Everyone knows what a function is, hopefully. So it's just like a function in computer science. You're setting the function, the formula for the turtle to go into, and out comes this movement or the direction or goal you want the turtle to accomplish. So these turtles are moving in circles, right? So why would they tell them to move forward versus just right? Does anyone have an idea of why you would want a turtle to move forward first before you had to turn right? Try to think back to like the example I gave y'all when you were directing me.
If you need like a little bit more space before you have to turn or something.
Yeah, exactly. So if you're just turning right, you're just turning right basically in place. So turtle geometry, another part of turtle geometry, I'm going to try to draw. Can y'all see like up here in the space?
Yeah.
Not really. Or I'll use this board. Okay, so let's say this is my turtle, right? So we want to move this turtle in a circle as the programmer. So the reason why we make it move forward first and then right is it moves in this direction, but this is a very small forward step before it turns right. So basically the circle that we make, let's pretend that's a circle, is not just a fluid line around a certain point in programming. You have to think about it mathematically. So a circle in turtle geometry is basically a set of individual line segments, kind of like this, right? So a circle, let's just say, so these are all connected line segments. So they're super tiny line segments that when you put together, it looks like from far away, basically a circle. So you can look at this circle as like a bunch of little dashed lines moving forward and just turning right just enough to make the circle. So basically a circle in NetLogo, they view it as a polygon. So what is a polygon? A polygon is a square, right? But the circle we use has a bunch, like an infinite number of sides. This is pretty conceptual, so try to bear with me here. An infinite number of sides to make it into like a fluid shape. Because there's just so many tiny little segments, it looks like it's in one whole circle. So does everyone understand that? Any questions? You understand it? No?
I'm no question.
No questions? Well, does anyone have any problems with that concept I just explained? It's a pretty important concept. Like, it took me a while to get it. Like, don't be afraid to ask. Everyone understands it? Like, first time around? Oh, classic geniuses.
So, pick someone to repeat back.
Okay, Alra, you nod your head. Let me know what's up.
So you basically said that every single time in the circle there's tiny little pieces of going forward and going right, going forward and going right.
Yeah. So it's just like, what is a circle is like a really intense polygon, like a dodecahedron times like a million. Like a bunch of little tiny sides, making like, it looks like a circle, but it's really just a bunch of little tiny segments put together. So that was a good like explanation. So like, that's what computer programming is. It's taking all these concepts in life where you're just like, oh, that's just a circle, that's just a desk, that you take for granted, like movement and motion, and it's breaking it down mathematically and then like using it to create like crazy patterns like that, or like even more complex stuff. Like you evaluate really intense calculus functions, or there's where you make an iPhone. Like computer programming like runs our society today. That's why it's so important. So basically, before like we get out, I want to show y'all like a really quick code. Like a really, since we only have like 5 minutes, I'm not going to make you figure it out because I don't think you'll have enough time. So in the command center right here, you can code your own movement. You can, hold on, let me make a new screen. So right here, this is your own little code box. And now that we have a blank model here, we can code the movement of the turtle any way we want. So right here, we create, as the programmer myself, I'm going to start creating this code. So the first line I'm going to input is create one. And that tells the program to create a tiny turtle, right? So I'm thinking this turtle's too small, right? So I use set size 3. Oh wait. Oh wait. My bad. You have to click. So the observer creates the turtle, and then to instruct the turtle, you have to change the function to turtles. And then you do set size 3, which makes it bigger. And then you want it to point north, so we're just standardizing our turtle right now. And then we put the pad function, the pen down function, so just like in turtle circling, it's going to be tracing the path. And then the most important part of the code, well, the most complex part of this code is right here. So everyone watch carefully. So I coded for the movement of a square right there, right? And I used this line. Does anyone have any guesses as to what that line means? So it might be kind of hard to see. So you gotta zoom in. Yeah, it's a type of function. It's like, it says repeat for, and in brackets, FD, which we know means forward 1, and then RT, which we know means right turn 90, and then wait 0.5, and then the bracket ends.
Basically telling you to do that stuff inside the bracket.
Yeah, so like what is it doing inside the bracket?
Telling it what to do.
But like specifically, what does FD1 mean? So what is it telling it to do?
Forward 1, right, 0.5.
Yeah, so it's moving forward 1, just like I was showing up there. It moves forward 1, it turns right 90 degrees, just like Lillian was telling me to turn right 90 degrees. And then it sets the time space, the speed it's moving at, in like a time space of 0.5 seconds, I think, whatever unit of time that logo works. So basically, it does that motion 4 times. That's why you use repeat 4. So basically, that creates a square, right? Because you're moving forward once, turning right 90, and then right 90 another time, and another time. So 90 times 4 is 360 degrees. So that makes 4 sides to a square, right? Everyone understand that? Because like a square has 4 sides, right? And 90 degrees at each angle. So let's say you wanted to make a pentagon, right? So how many times does everyone know what a pentagon is?
Yeah.
Yeah, okay. So how many sides does a pentagon have? 5, right? So how many times would you repeat what you're telling the pentagon to do? Yeah, repeat 5, right? And then how many degrees would you have it turn?
360.
Well, 360 is the entire thing, right? So it would be turning 360 5 times. You want it to do 5 segments of 360. 5 equal segments, since it has 5 sides.
75 degrees.
Is that, how'd you get 75?
360 divided by 5.
Is that 75?
That should be.
Oh, well, you got the basic principle, like 72 degrees, like, yeah, so you would make it turn right 72 degrees. So you can do that with any shape, a triangle, and that's basically like a really basic lesson on a type of computer programming. It's like, good job for that. All right, so like, we have, like, I don't know, like 5 more minutes, right? So in the last 5 minutes, you can mess with turtle circling, you can look at other models, just see what's cool, like, but also I want to survey real quick, like, who plans to pursue computer programming, like sees the importance of computer programming after this lesson?
Who's taking the class next year? Who's interested now in taking the class next year? Okay.
Yeah, it's important because like in college, like I went in like I never heard of programming before, and like there's a lot of people out there who are gonna be like, yo, I've been programming for years, and you're just like, what? So like if it's offered, you should take advantage of it because it's really important. It's also really interesting. So yeah, I encourage y'all to check it out.
Okay. So